Good morning, everyone. Now we are going to discuss about the response of low pass RC circuit for exponential input signal. Response of the low pass RC circuit for exponential signal. That means what is the response produced by the low pass RC circuit for exponential input signal, that is going to discuss about now. Just like a ramp signal, in exponential signal also there are two cases. One case is at where t is equal to 0, that means at t less than or is equal to 0, the input signal has 0 amplitude. For t greater than 0, the input signal increases exponentially. For t greater than 0, the input signal increases exponentially. And the exponential input signal is clearly defined here. V1 is equal to V into 1 minus e power minus t by tau 1. V1 is equal to V into 1 minus e power minus t by tau 1. This is for t greater than 0. And its value is 0 for t less than 0. Now the total cases of operation is divided into two cases. First case at t is equal to 0, t less than or is equal to 0. Second case at t greater than 0. For t less than 0, the input signal is 0. Whenever you can apply that signal to this circuit, initially we can assume that the voltage across the capacitor is taken as 0. Initially we can assume that the voltage across the capacitor is taken as 0. Now whenever you can apply a 0 input signal and there is no voltage across the capacitor is not responded for the input signal. Hence, the output voltage V0 is equal to 0 at t is equal to 0. That is the first case. First case represents at t equal to 0, input signal is 0, hence capacitor is not responded and the output signal is also equal to 0. Now coming to the second case, the input signal increases exponentially. That exponentially increasing signal is applied to the input terminals of low pass RC circuit. Because of this exponential input signal, the capacitor also charges exponentially through the resistor R. That means the charge developed across this resistor is in exponential motion and the output voltage follows the voltage across the capacitor. Hence, the output voltage also increases exponentially. The output voltage also increases exponentially. Therefore, for the exponential input signal, you can get the same exponential output response. Now, we are going to derive the mathematical expression for output response of exponential input signal. Now, we already know the general expression for low pass RC circuit. It can be written as Vi, that is equal to tau into dV0 by dt plus V0. And here Vi represents the exponential input signal. It is clearly defined here, that is equal to V into 1 minus e power minus t by tau 1. Substitute that value here, that is equal to tau into dV0 by dt plus V0. Therefore, V minus V into e power minus t by tau 1, that is equal to tau into dV0 by dt plus V0. Therefore, here the cases of operation is divided into two cases. Tau is not equal to tau 1 and similarly second case is when tau is equal to 1. Here there are two values. It is observed that in this equation there are two values, one is tau and second one is tau 1. Case 1 is when tau is not equal to tau 1, what is the output response produced by the circuit? Case 2, when tau is equal to tau 1, what is the output response produced by the circuit? Now initially let us take the first case, that is when tau is not equal to tau 1. Now when tau is not equal to tau 1, apply Laplace transform to this equation. We already know that here V is the constant value, therefore Laplace transform of 1, that is equal to 1 by S. Therefore V by S minus, here again V is the constant value, e power minus t by tau 1. Again apply Laplace transform to this equation, that is 1 by S plus 1 by tau 1. 1 by s plus 1 by tau 1. We know the Laplace transform of e power minus t by tau 1. That is equal to tau into, we know the Laplace transform of dv naught by dt, that is s into v naught of s, plus Laplace transform of v naught, that is equal to v naught of s. Therefore, v by s minus v by s plus 1 by tau 1, that is equal to, here v naught of s is common, v naught of s is common, therefore take v naught of s as common, therefore as tau plus 1. Again, take tau as common in this right hand side, therefore v naught of s into tau into s plus 1 by tau. Therefore, v naught of s, that is equal to, v naught of s, that is equal to, this entire term is moved to left side, that is v by tau into s into s plus 1 by tau minus v by tau into whole by s plus 1 by tau 1 into s plus 1 by tau. Just simply we multiply. Now coming to this, this term is moved to left side, therefore v by tau into s plus 1 by tau minus v by tau into s plus 1 by tau into s plus 1 by tau 1. Therefore, that is equation number 1. Now, for the simplicity purpose, the partial fractions is applied, is divided into two parts, that is one is x, that is first part, and second part. That means apply partial fractions separately for simplification purpose. The first partial fraction is equation is taken as x, next partial fraction expression is taken as y. That x and y are clearly indicated here. X is v by tau whole by s plus s into s plus 1 by tau, where y is equal to v by tau whole by s plus 1 by tau into s plus 1 by tau 1. Now the partial fractions, initially first calculate the partial fractions for x, next calculate the partial fractions for y. So for to calculate the partial fractions for x, let us consider this one, v by tau whole by s into s plus 1 by tau, that is equal to a by s plus b by s plus 1 by tau. Take LCM, therefore v by tau, that is equal to a into s plus 1 by tau plus b into s. When s is equal to 0, then we can get the value of a. When s is equal to minus 1 by tau, we get the value of b. Now first substitute s is equal to 0 here. Therefore, bth term is 0 and this is 0. Therefore, a into 1 by tau, that is equal to e by tau. Tau cancel, therefore a is equal to b. Next, to calculate the value of b, substitute s is equal to minus 1 by tau. When s is equal to minus 1 by tau, b by tau is equal to, this term is 0. Therefore, b into minus 1 by tau. Tau cancel. Therefore, b is equal to minus b. A is equal to b and b is equal to minus b. Similarly, x is equal to a by s plus b by s plus 1 by tau. A is v by s, b minus v by s plus 1 by tau, that is represented as equation number 3. Next, apply partial fractions for y, that is equal to v by tau whole by s plus 1 by tau into s plus 1 by tau 1. Therefore, it can be written as c by s plus 1 by tau plus d by s plus 1 by tau 1. v by tau is equal to c into s plus 1 by tau 1 plus d into s plus 1 by tau. Therefore, calculate the values of s, c and d. To calculate the value of c, substitute d is equal to minus 1 by tau. To calculate the value of d, substitute s is equal to minus 1 by tau 1. First substitute s is equal to minus 1 by tau. Therefore, when s is equal to minus 1 by tau, the tth term is 0. Therefore, v by tau is equal to c into minus 1 by tau plus 1 by tau 1. Therefore, C is equal to V by tau into minus 1 by tau plus 1 by tau 1. Therefore, C is equal to V by, take tau as common. When tau is taken as common, tau by tau 1 minus 1. Tau tau cancel. Similarly, here also, when SC is equal to minus 1 by tau 1, V by tau is equal to, C term is 0, therefore D is equal to minus 1 by tau 1 plus 1 by tau. D is equal to V by tau into minus 1 by tau 1 plus 1 by tau. Therefore, D is equal to V by minus tau by tau 1 plus 1. Therefore, T is equal to minus V by, take this one, take minus as common. Therefore, minus V by tau 1 minus 1. Therefore, this is the value of C, this is the value of D. Now, substitute these two values into this expression. Therefore, y is equal to C by S plus 1 by tau minus D by S plus 1 by tau 1. Now, substitute the values of x and y. Substitute the values of x and y into this expression, that is this one. Therefore, it can be written as V naught of S is equal to V by S minus AB. This is AB, this is CD. V by S minus V by S plus 1 by tau plus V by tau 1 minus 1 whole by S plus 1 by tau minus V by tau 1 minus 1 whole by S plus 1 by tau 1. So, here this is A, this is B, this is C, this is D. A is B, B is minus V, C is V by tau 1 minus 1, D is minus V by tau 1 minus 1. So, we get these values A, B, C, D. Now, apply inverse Laplace transform to this equation. V minus V into e power minus t by tau, V minus V into e power, apply Laplace transform. We already know that V into V, 1 by S inverse Laplace transform is 1. 1 by S plus 1 by tau, that is inverse Laplace transform is e power minus t by tau minus V by tau 1 minus 1 into 1 by S plus 1 by tau, inverse Laplace transform is e power minus t by tau plus, this is the value of t. So, minus and minus plus e power minus t by tau 1, because S 1 by S plus 1 by tau 1 inverse Laplace transform is e power minus tau by tau 1. Now, in this equation, that is equal to V minus V into, here also V into e power minus t by tau common, here also V into e power minus t by tau common. Take V into e power minus t by tau as common. Therefore, remaining can be written as 1 plus 1 by tau 1 minus 1 plus, this is as it is, V by tau 1 minus 1 into e power minus t by tau 1. Therefore, V naught of t is equal to V minus V into e power minus t by tau into, take LCM. Take LCM. So, whenever you can take the LCM, what happened? Tau by tau 1 minus 1 plus 1 cancel. Therefore, tau by tau 1 whole by tau by tau 1 minus 1 plus E by tau by tau 1 minus 1 whole into e power minus t by tau 1. Let n is equal, for the simplification purpose, assume that let n is equal to tau by tau 1 and x is equal to t by tau 1. Therefore, V naught of t, that is equal to V minus V into e power t by tau. T by tau. T by tau means x by n. X by n. T1 tau 1, T1 T1 cancel. T1 T1 cancel. And t by tau, that is equal to x by n whole into tau by tau 1 is n by tau by tau 1 minus 1, n minus 1 plus V by n minus 1 into e power minus x. What is x? T by tau 1. For tau is not equal to tau 1. for tau is not equal to tau 1. Therefore, V naught of t is equal to V into 1 minus n by n minus 1 into e power minus x by n. 1 minus n by n minus 1 into e power minus x by n plus 1 by n minus 1 into e power minus x. Here, because v is common, that is going to outside. So this is the expression for output response of low pass RC circuit for tau is not equal to tau 1. Similarly, when tau is equal to tau 1, the output expression is written as V naught of s is equal to V by s minus V by s plus 1 by tau minus V by tau into whole by s plus 1 by tau whole square. Now apply inverse Laplace transform to this equation. We already know that 1 by s inverse Laplace transform is 1. Therefore, V minus 1 by s plus 1 by tau is equal to V into e power minus t by tau minus V by tau into t into 1 by s plus 1 by tau whole square, that is t into e power minus t by tau. This is the expression for output response of low pass RC circuit for exponential input if tau is equal to tau 1. So this is the response of low pass RC circuit for exponential input signal. Okay, first initially we discussed the operation of the circuit, basic operation of the circuit. It has two cases. First case at t is equal to 0, second case at t is greater than 0. Thereafter, we consider the general expression for low pass RC circuit. In that, we substituted the value of Vi. Then, by simplifying this expression, we get two cases. One is tau is not equal to tau 1, second one is tau is equal to tau 1. So, when tau is not equal to tau 1, apply partial fractions to the entire equation. Similarly, when tau is equal to tau 1, apply partial fractions to the entire equations. You get four values a, b, c, d values. By substituting those four values and applying the inverse Laplace transform to that equation, we can get this one. Thereafter, by simplifying that equation, we can get this one. Therefore, when tau is equal to tau 1, directly we can apply the inverse Laplace transform to the given expression. Therefore, we can get this value. In this way, we calculated the expression for low pass RC circuit for exponential input signal.